Hello, hi everyone, welcome back to the channel. So today in this video lecture we're going to be solving this problem, Hamming distance. So in this problem we have a term Hamming distance which is present between two integers, and that represents the number of positions at which the corresponding bits are different. That means, let's say we have two integers, let's say 1 and 4. Let's write the binary representation of these bits. 1 can be written as 0, 0, 0, 1, and 4 can be written as 0, 1, 0, 0, right? So here we can see that these two integers, this is 1 and this is 4, right? What we want is we want to find the Hamming distance between them. That is, how many positions are there where the bits are different. The bits are same here, the bits are same here, the bits are different here, and the bits are different here. This is position number 0, this is position number 1, this is position number 2, this is position number 3. So let's see how we can actually find the positions which are where the bits are different. So here we can see that the bits are different here. How we can find it? 0, 1. If we XOR these integers, then we get 1. If we XOR them, we get 0. If we XOR them, we get 1. If we XOR them, we're gonna get 0. That means what we have here is the number of Hamming, the number of set bits. This is going to give me the XOR operation is going to give me the number of set bits which we have, right? So here we can see that 1 0, which are the bits at different positions, 0 1 the bits at different positions, and so on. So what we can do now, we have the XOR of these two integers, and in this resultant integer I am gonna find the number of set bits. How? It's easy to find the number of set bits in this resultant number. Why finding the number of set bits in the resultant number is enough to find the answer to a problem? Because this is the XOR operation between set bits, similar bits, and opposite bits. So we have here similar bits, it's gonna give me 0. We have similar bits, it's gonna give me 0. We have opposite bits, which gonna give me 1, right? So what we would have is 1 0 1 1, that is also going to give me 0, right? Now what we can do here is, if we XOR these two numbers 1 and 4, we'll be getting all of the bits set where the bits are different in the original numbers. Like here we can see that the bits are not same here. It's 0, it's 1. So they are different, that's why they're going to give me 1. They're different here, that's why they're going to give me 1. So the resultant number is going to be the one which is the resultant of these two numbers, right? Resultant of these two numbers means the set bits are only at those positions where the set bits are only at those positions where they are different in the original numbers, right? So this is my answer. So let's see how we can solve this problem. Now this is the answer, and how we can count, like counting the number of set bits in this integer will simply give us the number of bits which are different, right, in the original numbers. Fine. So let's see how we can do that. So this is our Hamming distance code, and in this Hamming distance code, let's first calculate the XOR of x and y. while we have this z, what we're going to do is we will be having, let's first declare an answer variable which is going to give me 0. So answer, so if this is not 0, what we'll be doing is if the last bit of this z will start from the last bit or the first bit. So this is my resultant number. I'm going to check if this is actually set or not. So 0 0 0 1. So if I AND these two numbers, then I'm going to get 1, right? Fine. So 0 1 0 1. So this is removed. I'll have 0 1 0 0. Then I'll have 0 0 1, right? This is out. Now I'm going to AND these two numbers again. This is going to give me 1, this is going to give me 0, this is going to give me 0, and that's going to give me 0. Means the last bit of the original number is unset, or the second bit is unset. Now we remove this and we again have 0 1, then we'll have 0 1 again, and let's AND them. We'll have 0, we'll have 0. So this is going to give me 0, right? Now we'll have 0 1 0 1. So fine. So that's my answer. Now let's remove the last as well. So we'll have 0, we'll have 0. So let's put 0 XOR 0 to be 0, right? Now this is my answer. 0 is my answer. Let's remove this 0, and now what we have to do is we have to actually find the answer. The answer is 2, because the answer is simply how many times the resultant becomes 1. The resultant of n and 1 is going to give me 1, right? That's my answer. So if z and 1 is, then we're gonna increment the answer by 1 and simply remove the z, the last bit of this z, by 1. So how we can remove the last bit? Z, divide this z by 2, right? So this is, or another way is, we have, let's say we have an integer 0 1 0 1, then what we can do is So what we have to do is we have to, so we have the number that says 0, 0, 1, 0, 1, right? We can simply perform the right shift, that is shift the bits by right by 1. So we're gonna give 0, 0, 1, 0, right? So that's gonna give, this bit will be shifted, right? So this is my new answer, 0, 0, 1, 0, right? So what's this going to give me is, it's going to give me the final answer, which is this. And that's how we remove the last bit, that is by using this right shift operator. So we're shifting the bits towards right. Fine. So here let's shift them towards right. Let's return the answer from here. So let's run the code. Okay, so that's how it worked. We simply left shifting the bits by 1. Why did we left shift the bits by 1? Is to simply remove the last bit so that we can end them with 1. So we had 0, 0, 1, 0, 1. Then we had 0, 0, 0, 0, 1. Let's end these two numbers. We're going to get 1, 0, 0, 0, 0. So let's remove the last bit by using the left shift operator. We'll have 0, 0, 1, 0, right? Then we'll have 0, 0, 0, 1. So here we'll again have this AND, then we're gonna get 0, 0, 0, 0. So after that, we'll have 0. So we can see that the last bit is unset, that's why let's remove it. We'll have 0, 0, 1, 0, 0, 1. Let's AND them, we'll get 0, 0, 1. Let's remove the last bit of this number, we'll get 0, 0. Then let's AND it with 1, let's say 1, 0. Okay, so that's how we do things. And we can finally we'll have our number of set bits. So whenever we get 1 here, we're going to increment the count by 1. Whenever we get 0, we simply skip, right? So that's what we are doing here. Whenever we get 1 here, we increment the answer by 1, and so on. So let's try to submit it. Okay, so that got accepted. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel. We'll see you soon in my next video. Till then, take care. Bye bye.